Welcome to today's video. If you've ever needed a hands-free way to analyze data files daily without managing servers or complex infrastructure, this guide is for you. Today, we'll explore how Amazon Athena, together with AWS Lambda, S3 and EventBridge, can automate your data analysis pipeline efficiently and cost-effectively. Imagine having data files arrive in S3 regularly and wanting to pull insights from them every day. With Amazon Athena, querying this data is as easy as running SQL queries. No database setup or service required. Athena works directly with data stored in S3, letting you run complex queries and analyze massive data sets on demand. To make this automation seamless, we'll leverage AWS Lambda for automated triggers and EventBridge to set up a daily schedule, keeping your data analysis fresh without any manual intervention. This combination is powerful, flexible, and scalable, and you're free to focus on insights rather than repetitive tasks. Athena is fully managed, serverless, and you only pay for the queries you run. It's ideal for handling tasks like processing logs, customer data analysis, and report generation, all in one integrated solution. And here is the best part. This video is a complete how-to guide with detailed instructions, scripts, and a source code you can download from our GitHub repo. You will find everything you need to practice in your own AWS account and build a similar setup from scratch. So, let's get started and see how you can bring this powerful setup into your own workflow. Probably the best place to start is to answer the question, what is AWS Athena? Well, it's an interactive query service that uses standard SQL to help you query your data directly in S3. It can help you analyze unstructured, semi-structured, and structured data. And your data lives in S3 and is never modified by Athena. In fact, Athena uses something called a schema on read query engine, where the original data remains unchanged in S3. The first question is, what is a schema? Well, it is a structured framework that defines the organization, relationship, and constraints of data within a database, including tables, fields, keys, and relationships between your data. It is essentially the structure or outline that defines what types of data are stored, like column names or attributes, and how they are organized, while the rows of that table are the actual data entries that fill in this structure. It's like having column headers on a spreadsheet, defining the kind of information each row will contain. So let's talk about schema on read query engine. What exactly is that then? Well, schema and read query engines that are provided with the likes of Amazon Athena or Apache Hive defers the schema application until the time a query is actually executed. This is unlike a traditional database where you need to specify and build the schema and then ingest data that is aligned to that schema into the database table. With schema on read, data is stored in its raw format in a storage container such as Amazon S3. That could be CSV, JSON, Parquet, whatever the format is, without needing you to define a fixed schema beforehand. When you run the query using a product like Amazon Athena, a schema is applied to interpret the data structure. Users define the schema in terms of the expected column types and the formats within the query or via some external table, as in the case with Athena. And then this schema acts as an overlay, instructing the query engine on how to pass through and interpret that data in its raw format in Amazon S3. So as the data is being queried, the schema is being applied to the external table that Athena will host for you. Also, the engine will only pass relevant parts of each file as per the query, providing that flexibility in querying varied data sources. And so you do need to actually define a schema, but you do so in the external table that Athena hosts. The raw data stored in S3 remains unchanged. You can also use another product called AWS Glue, which is a service that performs extract, transform, load operations and can help you crawl through your raw data in order to decipher what that schema needs to look like. It's serverless, so there's no infrastructure needed. You're not going to spin up database instances like you do with RDS, for example. Okay, you basically pay $5 per terabyte of data scanned. Data can be in CSV, JSON, or columnar formats such as Apache Parquet or Apache ORC. And you can also use Amazon QuickSight for quick data visualization. Athena integrates with QuickSight really well. Now, before I actually show you how you can build an automated solution with Amazon Athena, Lambda, and EventBridge in order to build a scheduled analytical pipeline, I thought it'd be a good idea to present to you a real-world use case for a fictitious company called Belly Brew Limited, who have a specific requirement where Athena can actually be the best solution for them. Let's discuss the customer requirements. And so I'd like to introduce you to our client, Belly Brew Co. Limited. They're manufacturers of gut-friendly food products and beverages like kombucha, kefir, yogurt smoothies, kimchi, and much more. And you know how the current trend is. Look after your gut and you'll have a long, healthy life. So let's take a look at what exactly the requirements of this client is. Now, Belly Brew Co. Limited have come to you. You're the solutions architect and they need your help. Let's talk a little bit about what they actually do with one of their product ranges. So they manufacture something called kombucha, which is basically fermented tea. And you can have them on all kinds of different flavors: ginger, lime, raspberry, strawberry, whatever you like. The list is endless and the beverages are amazing. They taste great and they're really wonderful. And if you haven't tried it yet, do give it a try. But obviously, this isn't any kind of medical advice. In any case, the way how it works is you've got sweet tea that you then add Scooby to. Now, Scooby stands for symbiotic culture of bacteria and yeast, and it's living culture used to ferment kombucha. Once that happens, you then go through a process of fermentation, and that takes a little bit of time, obviously, before you actually end up with the final product, which is your bottled or canned kombucha drinks that you can buy off the supermarket shelves. Anyway, I digress, so let's get back to the requirements. Belly Brew Co. Limited have a current process when it comes to casks safety checks. So the drinks that are being manufactured and fermented are getting fermented in these casks. In order to ensure that the beverage is safe for consumption, it goes through a process of testing. So as the casks are getting filled with this kombucha beverage and it goes through the production line, a process happens where each cask is tested and it's tested for specific parameters that they're looking for, which is carried out by a third-party monitoring tool that Belly Brew uses. Now, this monitoring tool then analyzes the contents of the casks and produces a report and tells you whether the cask passed the safety check or failed the safety check based on the parameters that were determined in those tests that were carried out. What happens then is that this monitoring tool, once it's completed its check, it produces this report which is then sent to a dot matrix printer. Now, I know what you're wondering. What is a dot matrix printer? A dot matrix printer is an old school device that prints by creating tiny dots with pins and an ink ribbon. And I'm just going to quietly dodge any questions about my age. Regardless, the point that I'm trying to highlight here is that the current architecture of their safety checks results in this manually printed document that staff members at the manufacturing plant need to review and identify which casks need to be removed from the production line because they're no longer safe for consumption. So let's take a look at the requirements. So the requirements are as follows. Belly Brew Co. Limited would like an automated reporting solution. They don't want someone manually going through this printout from this old-fashioned dot matrix thingy. In addition to that, they'd like the checks to be performed once a day at 5 p.m., which means that these checks need to be run every day on schedule for the day's casks that have been filled with the beverage. The data must be stored for 12 months to fulfill any compliance requirements. However, it's only required in rare circumstances, like if there's a huge problem and they need to be audited or something. In other words, the daily reports that are being generated by this third-party application are seldom referred to, except for the day on which they were produced, in order to identify which casks need to be removed from the production line. Nevertheless, the reports need to be kept, and as it stands at this point in time, because this is a physical report, they've got piles and piles of these dot matrix printed sheets sitting in the warehouse. The third-party app provider is now upgrading the software, where the application will be able to produce a CSV file for reporting. We've come to the digital age. And so George, our CTO, has a requirement. Our goal is to automate this manual process to get the report of tasks that need to be removed from the production line. We must keep costs to a minimum. The reports are used only once, and we do not need to change or manipulate the data in any way. So the data needs to be a single source of truth. We need to be able to identify on a daily basis which tasks are safe, and so which can be sent off for bottling, and which tasks need to be removed because they've failed those safety checks. Simple. Let's take a look at the architecture diagram on how we can use Athena to fulfill George's requirements. Okay, so let's talk about the solution with an architecture reference diagram. Now I have one simple request. If you have an alternative solution and you would like to propose that solution, feel free to add it into the comment section below. Let's try to keep this YouTube channel interactive. It's really helpful for everyone going through these videos. So my solution is as follows, and this is what I highly recommend you implement in your AWS account to test the solution out. So we've got our monitoring application. Okay, this monitoring application, as we've been informed by the third party, has now been upgraded in that it produces CSV file of the analysis of those tests against all of the tasks. Now what we can do is we can have this monitoring application upload the files to an S3 bucket that we manage. All of the CSV files can be contained in this S3 bucket. And then we can use Amazon Athena to analyze that data. This is how it would work. You would need to create the S3 bucket with 3 separate subfolders. You can have 3 separate buckets if you like. The choice is yours, but I was just trying to keep things a little bit simple. So you will be creating an S3 bucket with 3 folders: raw data, Athena, and processed. The raw data folder is going to be where the actual raw data sits from the monitoring application, the CSV file that needs to remain unchanged, which we're going to analyze and extract information from. The Athena folder is basically used to record any query results from the operations that are performed by the Athena service itself. I'll come on to the processed one in a second. At the same time, you will also be creating an EventBridge rule. This EventBridge rule will be configured to invoke a Lambda function at 5 p.m. on a daily basis. And so the Lambda function is where the heart of all of the operation resides. The Lambda function is what's going to actually execute code to perform all of this wonderful magic. Essentially what the function is going to do, and I'll show you the code shortly, it's going to capture the current path and the current date, which is the day the operation is being performed, and then use that information to invoke a query using Amazon Athena. Amazon Athena is then going to use a schema on read engine to pull and extract the information in the raw data into a table that Amazon Athena has, which it will use to query the data. It will then identify those tasks that have failed the tests and produce a CSV report, which it will then deposit into the process folder. A staff member at Belly Brew Co. Limited can then go ahead and review those process reports and identify all of the tasks that need to be removed from the production line. Let me just quickly show you the Lambda code that's available in our GitHub repository, the link of which is in the description box below. Okay, so let's actually take a look at the code that you'll be using for your Python function. Okay, so this is written in Python, and so we want to just quickly go over it to look at some key points, and then you will be able to use this code. It's available to you from our GitHub repository, the link of which is in the description box below. So we start off with some basic import of standard libraries that we need in order to work with this function. So for instance, we want to obviously import Boto3 because we're working with AWS, and then there's also a time function that we use later on. In addition to that, we are initializing Athena and the S3 clients. Now this is where you do need to actually provide some variable names. So you need to put in your S3 bucket name. I've got mine written in there as Belly Brew Monitor, but obviously you'll need to select a different name, and then a database name as well. This is what the actual Athena service will create in order to create that external table with. Okay, so you need to choose a name of your choice. So this can be anything you like. So these two are going to be variable names for your S3 bucket name and your database name. Now this code allows you to create essentially 2 functions. You've got the create table function. This runs if there isn't an external table already created, so it pretty much does it once. But this is where it defines the actual schema of that table. Remember, this is an external table in Amazon Athena. Okay, it doesn't make any changes to your actual raw data. But the key values in here is where the magic happens. So we've got cask ID, cask name, cask type. This is just related to the cask. The kombucha flavor, Don't know what's your favorite, but mine's raspberry. And then these three refer to some bacteria and yeast variants that are basically live culture that is in the kombucha drink, okay? And it needs to be of a specific quantity in order to fulfill the requirements of being called a kombucha. But we'll not get into that. Obviously, that's all the science bit, and that's not our domain of expertise. Next, we've got the pH level. So the pH level is actually what we're going to be checking, okay? So this third-party application that produces this report gives us a list of all of the pH levels of all of the tasks in the production line. And pH level refers to the acidity level of the actual beverage. So this needs to fall within a specific bracket, a specific range, 2.5 to 3.5, in order for the kombucha drink to be safe to drink and to be, a kombucha drink, basically. That's the range that it needs to be at. Anything outside of those ranges, and then we may have a problem. We don't want it too acidic. We don't want it alkaline, all of that stuff. Okay, so our Lambda function is actually checking for this. Okay, it's going to use Athena to run a query to see whether the pH level is outside of the range specified, in which case that is when that particular cask is considered as unsafe and needs to be removed from production. Some of the fields there, again, it depends on the use case, but I've just got all of this in there for context. We're storing the file as a text file in the folder raw. So when you create your S3 bucket, you need to create 3 subfolders: raw, Athena, and processed. This S3 bucket is basically just picking up that variable name where we've specified earlier. So it's going to pick up belly brew monitor. In my case, you obviously will choose a different bucket name. It's going to run through an initial query and set up that table. And we've got the Athena folder, which is where it's going to store any results of queries, specifically if there is a failure in running the query. Okay, that's going to show up in that folder. So this Athena folder is being used by Athena itself for its querying, processing, and all of that stuff. And so the results are basically stored in that folder of those queries that it's just run. Now, it's going to go through this operation. So if there is a failure, then it's going to tell you that query failed to run. If it's cancelled, likewise. If it's a success, then obviously it succeeded. The next function is the main Lambda handler, and that is going to use the current date. So it's going to take the current date in that format, so year, month, and day, and then call the create table function and then run a query against the data. Okay, so remember, the table has already been created now. It's got, all of those parameters in there. So now it's going to run the query. And so it's going to select everything from the database name. So the database name here is a variable. Again, the variable is defined right at the top. There it is. Okay. And that is going to basically do a select all from that database, from the raw data table. And it's going to look for any entries where the pH level is either less than the 2.5 or greater than the 3.5. Okay, so within that range, we're safe, we're good. We can use the beverage, we can use the cask and start bottling. Anything outside of that range, it needs to be removed from production. And part like current date. So we are actually making use of the current date, because remember, we're going to run this operation every day. You don't want the Lambda function running against data that's yesterday's, because it's done it yesterday. So you want the Lambda function to run against the current data that's being deposited into the S3 bucket today, okay, if we're running it today. So that's why we're using that path there. Okay, so next we've got the actual query execution, okay, and this is where the query is run in Athena and the results are saved in a date-specific folder. So here we are actually making use of that current date. We're putting it in the process folder. This is where the results of that query operation is going to go, but we're going to put it in a subfolder called current date so that it matches up with our current date of the raw data as well. So if the raw data was received today, we ran the query today, we want the process data to be available under today's date as well so that we can tally it all up. So that's the results configuration. That's where it's going to go. We then obviously perform the query operation and wait for it to complete. And then finally, we've got the results query location, which is where we are constructing the expected S3 part for that query result file to be deposited into so that it goes in there. And you'll note that we are basically making use of the query execution ID and also adding a .csv extension against the file so that we can easily open it up in something like Excel or some sort of other CSV tool that we want to use. And so finally, it returns a success message and the S3 location for the query result in this JSON format. And so what happens is once we've got the result, it now knows that it needs to deposit into the results S3 location, which is that path. Okay, very simple, not too complex. So let's go ahead and jump into the AWS Management Console and set all of this up. Okay, so here we are in my AWS Management Console. We are in the development account, and this is the North Virginia region. So the first thing we're going to do is actually set up that S3 bucket, which is going to be used to host all of our raw data, allow Athena to run its queries, and also deposit the processed data into a subfolder. So let's go into Amazon S3. Okay, I've got various buckets in there, but we'll create a brand new one for this exercise. Remember, this bucket name is the name you need to put into the actual Lambda code. So we'll call this Belly Brew Analysis. I'm using a slightly different name here. Okay, if I scroll a bit further down, and I can just click Create Bucket. So hopefully I will get that name. Yep, I did. Fantastic. So no one's taken that name. So Belly Brew Analysis it is. And so what we need to do is create 3 subfolders in there. So the first one is going to be called Raw. Okay, we'll create Raw. Okay, I'll create another one. This one's going to be called Athena. And then a third one, we're going to call this one Processed. Okay, simple. So that creates our 3 folders in our bucket, and there they are. Okay, so next we need to go into Athena and configure Athena with a database that will be used to host the table that will contain the data that will be extracted, or rather queried, from the S3 bucket. So let's do that next. Let's get into Athena. Okay, so here we are in Athena. So the first thing we actually need to do is click on this Query Editor tab. Now, before you actually perform any queries, you need to set up the query results location to point to your S3 bucket. So here we've got it shown here because this is a brand new account, but otherwise you'll find it under Settings. So just click Edit Settings. And this is where you're going to actually provide the path to your query results. Okay, so this is the results of your queries as it runs through. Remember, Athena needs a location to deposit any messages or any failed attempts or whatever. Okay, so we're going to click Browse, and we're going to point to our Belly Brew Analysis bucket, and specifically the Athena folder. Okay, so choose that one, click Save. Okay, and those are the settings updated. Go back to the editor, and now what you want to do is you want to run a command to basically create that database. Okay, so the command is fairly simple. It's create database, and then the name of the database, Belly Brew Analysis _DB. That should do it. Oops, semicolon at the end of that. And then what you will be able to do is click on this Run button. If you don't create that S3 location, the Run button isn't available to you. So click Run. And it says query is completed, and it's created the database for you. So there's a default database and a Belly Brew Analysis _DB database. This is the database where we're going to create that table that will have the schema that can be used to understand the data. Okay. Okay, so next you need to create an IAM role. The IAM role is going to be used by Lambda. Lambda needs the IAM role in order to communicate with Amazon Athena and Amazon S3. Okay, because if it doesn't have a necessary role with the right permissions, the Lambda function will fail. So let's do that next. Okay, so next we're going to go into IAM. So I'm going to open that up in another tab. And we're going to go into the Identity and Access Management Service. And from the left-hand menu, you'll need to select Roles. And we're going to create a new role. And this time it's for an AWS service. And so the trusted entity type is going to be AWS service, and the specific use case is going to be Lambda, because Lambda is the one that's going to be able to assume the role. Okay, so you click Next, and I'm going to give it some broad level permissions because I didn't want to get too detailed on the permission side of things, purely because we want to try and talk about Athena in this lab. But in the production environment, you probably want to make your permissions a bit more granular. But essentially, you're going to need 3 roles that your Lambda function is going to assume. So you've got the S3. We're going to just do full access there, make things easy. Then you've got Athena. So we are going to grant Amazon Athena full access as well. And then there's one more role you need to attach. That's the Amazon API, this one. Amazon API gateway push to CloudWatch. Now the reason for this one is so that we can have CloudWatch populated with the necessary log files from the results of those queries as well. So you need this particular policy as well. So go ahead and click next, and then obviously give your policy a name. So I'm going to call this one belly brew IAM policy. Okay, scroll all the way down and click create role. Okay, so now that the role has been created, the next thing is let's go ahead and create the Lambda function. Okay, so to create your Lambda function, obviously we need to go into Lambda. So just search for it in the search box and open it up in another tab. So here is Lambda. Okay, and we're going to create a new function. Click create function. We're going to be authoring it from scratch. Need to give the function a name. So I'm going to call this one belly brew Athena function. Okay, something like that. The code is written and compatible for Python 3.12, so that's the one you want to go for. Remember, it's the x86 architecture, and then you need to provide the role to your Lambda function. So expand this one over here that says change default execution role, use an existing role, and you want to use the belly brew IAM policy role that we just created, and then click create function. Now with the function created, there's one thing you need to do. Remember that the function is going to wait for Athena to run through the query. Okay, so if you go into configuration, you want to increase this timeout period. Okay, it's a little bit difficult to gauge exactly how long it will take. I mean, it just takes a few seconds. You want to give it some additional time. So what I would do is I'll just select 1 minute. Let's just put a 0 in there. Okay, so 1 minute. I mean, it wouldn't take 1 minute, but we're giving it that much time before it times out. Okay. And if we scroll a bit further down, yeah, it's using the right IAM policy. So I'm just going to save that. So essentially you just increase the timeout period to 1 minute. Okay, now with that in place, if you click on code, okay, and what you can do is you can just upload the code, but you remember you do need to make a change to the code. So let me just bring up the code again. Okay, so there's my code. So I've renamed my S3 bucket to belly brew analysis. I'm just going to quickly check that I've spelled this correctly. Okay. Belly brew analysis. Yep, I have. Okay, don't want to make a mistake there. Okay, and obviously our database name is belly brew analysis _db. Okay, so we've got that right. You need to make sure you get this right, obviously, or else it will fail. So with that in place, let's go ahead and copy the code. So I'm just copying it to my clipboard. We go back to the Lambda function and we're going to paste it in there. Okay, so that's our code pasted in there. Next thing you need to do is you need to click deploy. Obviously, if you don't click deploy, then the code is not in effect. So you want to deploy the code and get a deployment successful message there. So that's pretty much done. So now you have the Lambda function in place. It's got the IAM role it needs in order to talk to S3 and the Athena database and the table. So it's ready to go. We obviously have a requirement that we want to run this operation on a daily basis at 5 p.m. So the next thing to do would be to set up a scheduler to trigger this Lambda function. That's what we need to do next. Okay, now to create this scheduler, you need to use another product called the Amazon EventBridge service. Now the Amazon EventBridge basically allows you to target different services on the AWS platform based on an event that has occurred or on a specified schedule. So it offers this scheduling service that you can use to trigger this Lambda function. So let's do that. We're going to go into Amazon EventBridge. And I'll just open that up in another tab. Okay, and so this is EventBridge. Now with EventBridge, what you need to do is you need to create a rule. So we click on rules and then click create rule. And we'll give this a rule a name. We'll call this one the belly brew cask task scheduler. Give it a description if you like. Now, how is the rule going to run? Is it based on an event pattern or a schedule? It's based on a schedule. So select that one and then click continue in EventBridge scheduler. So next you want to select the schedule pattern. So it's a reoccurring schedule rather than a one-off one. So we select reoccurring, and then you've got two options. Either you can build what's known as a cron-based schedule, which is where you specify things like the day, the week, the month, the time of the actual day you want to run a job, or a rate-based schedule, which is where you want to run something every X number of minutes or hours, that kind of thing. We're going to go with the cron-based schedule because we need to run this daily at 5 p.m. Okay, and so you need to provide the cron expression for that particular schedule. Now, if you're new to cron expressions, all you have to do is click on this info button, click on manage cron-based schedules, and you can get a guide on how to set it up. So the syntax is fairly simple. Your minutes, hours, day of the month, day of the week, year is all defined by these values. And so you can use these values or wildcards to basically populate your cron expression. So our minutes are going to be 0. Now our hours should be 1700 hours, 5 p.m. Because I'm running this as a test lab, I don't want to wait till tomorrow. It is 7:45 in the evening over here. So I'm going to go ahead and put 20 for 8 p.m. in the evening, 2000 hours. We're going to run this every day, every month, every year. Okay, just to test this out. Probably don't need to do it that broad. Obviously, this is going to be based on your use case. Flexible time window, I'm going to turn that off. We don't need that. And so basically, this schedule is going to trigger our Lambda function every day at 8 p.m. in the evening, based on my time zone. So if I scroll further down and click next, now you need to select the target for that schedule. What is it that that schedule is going to do? What's going to happen when it becomes 8 p.m.? Well, it's going to invoke my Lambda function. Which function? It's going to invoke the Bellybrew Athena function. Okay, scroll down and click next. What should you do after the schedule completes? Continue, right? We don't want to delete it. We want to keep that scheduler because obviously it's going to happen every day. You've got retry policies and dead letter queue configurations over here. That's another video. Okay, so I'll skip all of that at their default values for now. And also, EventBridge needs to create an IAM role, or it needs an IAM role in order to interact with Lambda. It can create the role for you, so go ahead and let it do that for you. Click next. So this is the summary page. Every day at 8 p.m. my schedule is going to invoke this Lambda function. Okay, scroll all the way to the bottom and click create schedule. Okay, so your schedule Bellybrew cast test scheduler is being created. Okay, so that's pretty much done. The status is enabled. We're good to go. At 8 p.m. today, this schedule is going to invoke that Lambda function and is hopefully going to perform the analysis on the raw data that's in my S3 bucket. Now, what about the actual data? Because there isn't anything in the S3 bucket. Let's go back to the S3 bucket, go into the raw folder. Nothing's going to happen if you don't put the data in there. Okay, so I've got a sample CSV file for you again in our GitHub repository. Remember to download that as well and upload that to this folder so that it will work. And so what I wanted to do very quickly is show you the sample data. Okay, so you've got cask ID, cask name, cask type, kombucha flavor, the bacteria and yeast thingy, and the pH levels. So obviously those look good to me. Okay, yep, we should be okay with this. Oh, but that one, if the Lambda function works well and Athena does the job it's supposed to do, it should highlight that one, which is a peach flavored kombucha in the Alice cask. Okay, it should pull that one out as one that we shouldn't be putting on the production line, that we should remove from the production line. So we'll see that when we let it run. Okay, so what I'm going to do is I'm now going to close this file down because we need to copy it to the S3 bucket. Okay, we're back in the S3 bucket. Now remember, the Lambda function is only going to try and retrieve the file from a folder that is of the current date. So the folder name should be the current date. So you need to be really careful here. So that means that when this third-party application is uploading files to this bucket, it should be creating the folder based on the current date, or at least the folder based on the current date should exist in this bucket. So the first thing you want to do is actually create that folder. Okay, so we're going to create the folder. And so the date today is the 28th. Yep, that's the correct date, 2024 10/28. And then I'm going to create that folder. And in that folder, now I know the purest of you are going to turn around and say, hey, this isn't a folder, it's just a prefix. I get that, okay, but it looks like a folder. But obviously, we all know that in S3, we have a flat file structure, okay? We don't have a hierarchy of directories and subdirectories, except obviously when we look at the directory version of the S3 bucket, which is again topic for another video. Okay, so without digressing, I've got my folder 2024 10/28, and what I'm going to do is I'm going to drop the file in that folder, okay, and click upload. Okay, so that's my file uploaded, and it's called kombucha cask CSV. It is in the raw folder in a subfolder called 2024-28. So we can just make sure of that. Let's just go back. Raw. Yep, there it is. Okay, so the data is there. The schedule has been set to run at 8 p.m. and the time now is almost 10 to 8. So what we're going to do is I'm going to pause the video over here, let this run, and then I'll come back once it's all done. Okay, so welcome back. It's past 8 o'clock and the Lambda function should have run and Athena should have analyzed my data in the CSV file. So let's go and see if it did what it was supposed to do. If we go into the bucket, click on processed, we've got a folder in there. Okay, that's a good sign. And we've got a CSV file in there. There it is. It's 2 kilobytes in size, so not very big. Let's just open that up. Click open. And I'll open that up in Excel. Okay, so this was the file that was created by the Lambda function, drawing the query results from Athena. So you can see that we've got some casks here, not all 500 items. And in fact, there is the cask ID 16, the Alice one, the peach kombucha that had a pH level of 4.72. It picked that up. And in fact, it's picked up all of the other casks where the pH level is outside of that range between 2.5 and 3.5. Fantastic. The job actually worked and it ran on schedule. The Lambda function was invoked. The data was analyzed by Athena and Athena produced another CSV file and deposited or uploaded it into the process folder under the current date. Excellent. This is exactly what you wanted. And what I can also show you very quickly is we can go into CloudWatch, and let me just open that up in another tab. Click on log groups, and there should be a log created for this. So there it is, Belly Brew Athena function. Okay, and we can see the log streams, and there is the log stream. And if you open that up, you can see that indeed it started at 8 o'clock in the evening, 19 seconds. So initializing runtime version, Python 3.12. There is the Lambda function with the ARN, and we can expand that. You can see exactly what happened. There's when it ended. So it started at 20:00:19. Request ended at 20:00:40. And there you go. So the duration is available to you in milliseconds. The build duration is that. Fantastic. The job was done. Lambda was successful. And if we go into Athena, and there it is, it's actually created that raw table as well. Perfect. Okay, that's exactly what we wanted. Okay, so as you can see, the Lambda function was successful. Okay, the whole architecture required by Belly Brew Co. Limited is now functioning and in place. Now, obviously, there needs to be a mechanism by which you can actually upload those files directly into S3. Now, we manually uploaded the file into S3, but I want you to just imagine that there is this third-party application that's making API calls to the S3 bucket. Okay, and so obviously, Belly Brew Co. Limited would need to work with a third-party monitoring service provider to ensure that that CSV file can be directly uploaded to the S3 bucket by making API calls. If you enjoyed this video and you found it helpful, then I really make a humble request, and that is please like, subscribe, and share this video with your friends and colleagues who are in the IT industry or working with cloud computing or working on the AWS platform. If you're preparing for the AWS certification exams, hopefully you got some hands-on experience. If you're looking for a new job in the AWS ecosystem, hopefully you can use this project as one of the tasks that you completed as part of your interview to showcase how much hands-on experience you have. I'll see you folks in the next video. Thank you.